Namaskara. Today let's learn about NOx sensor. In this video we will learn what is NOx sensor, how does it work, what are the consequences of knocking.
A few inches later.
Now let's understand this diagram. Here I have taken a 3-cylinder engine as an example. This is a cylinder block. These 3 are spark plugs and these 3 are fuel injectors. And this part you are seeing is NOx sensor and it is connected to ECU. And ECU is controlling spark plugs and fuel injectors. Here you can even observe KS1, KS2 and KS3. These are NOx sensor assigned to each cylinder. That is KS1 is for cylinder 1, this is for cylinder 2, this is for cylinder 3. Now let's understand what is knocking. For this, first we need to understand how combustion takes place in an IC engine, that is internal combustion engine. In a typical 4-stroke engine, there are 4 strokes or 4 cycles, namely intake cycle, compression cycle, combustion cycle and exhaust cycle. In the intake cycle, as we know, piston moves from top dead center to bottom dead center, sucking in air and fuel mixture. In the next cycle, that is compression cycle, piston moves from bottom dead center to top dead center, compressing air fuel mixture. During the combustion cycle, a spark is initiated and combustion takes place. Here we need to focus on one thing, that is, as the piston is moving from bottom dead center to top dead center, it is compressing air and fuel mixture, that is building up a pressure inside the cylinder chamber. There is a thing called MBT, that is maximum braking torque. This condition is usually achieved when the cylinder pressure is at maximum. It becomes the optimal time for spark initiation. If the spark is initiated at an MBT position, we will get maximum performance out of an engine. That equates to maximum efficiency. As soon as the spark is initiated on the top and combustion starts, a flame wave front starts moving downwards. This is called controlled combustion. Now imagine a condition, this wave front is moving down, but simultaneously another combustion or another detonation happens inside the cylinder and both these wave front collide. This situation is termed as uncontrolled combustion or undesired combustion. That is because we were expecting only one wave front, instead of that we are getting 2 wave fronts. This collision leads to high frequency noise or pinging and it is picked up by this NOx sensor. Basically NOx sensor has piezoelectric element in it. The functionality is similar to microphone, that is it is picking up sound waves or noise of different frequencies. And the definition of piezoelectric element is it converts a mechanical energy into electrical energy. That is, when a sound is produced, it makes the piezoelectric element deform a little. That mechanical energy is converted into electrical impulses that you can see here. That is, these are different frequencies that is picked up by NOx sensor, and these peaks what you are seeing is knocking. If you observe this diagram, there are different kinds of peaks. Here there are 2 very high peaks and very low peaks, and others are similar in nature, and there is a threshold frequency limit. These 2 are exceeding the threshold frequency, that is termed as knocking. That is, this is the first knocking, this is the second knocking, and this waveform belongs to only one cylinder. That is, we can detect which cylinder is knocking. After detection of this knocking, the first thing ECU will do is retard the timing. Now let's get to this part, reasons for knocking. First one is poor spark timing. That is, if the tune in the engine is not proper, that is ECU is not able to accurately time the spark plugs, that is either advancing or retarding. Next one is improper AFR ratio, that is improper air fuel ratio. This can be because of poor quality of fuel or clogged air filter or many other parameters which learnt in our earlier videos. Next one is faulty spark plug. If the spark plug is too old or it has a carbon deposit on it or the clearance gap or spark gap is not proper, we can observe knocking. One more important reason is unburnt fuel or oil or grease which have been deposited on the cylinder walls may ignite themselves due to high temperature in the cylinder, which leads to second combustion and it collides with the first combustion, thus resulting in the knocking. Now let's understand what are the symptoms of faulty NOx sensor. First one is reduced performance, that is engine's horsepower, torque and acceleration, everything comes down. And it even affects the fuel economy, and ECU always keeps track of how many knockings happen per cylinder. If it crosses a certain threshold, it leads to a fault code generation and illumination of MIL lamp, that is malfunction indication lamp, in your dashboard. This fault code is cylinder specific, and in severe cases of knocking, ECU might put engine in the limp mode, that is limiting the RPM to around 2500 or 3000 RPM, thus forcing the driver to take it to service center. We can even see situations where there is difficulty in starting of the engine, and as we learned earlier, this knocking is the result of uncontrolled combustion, that is whenever uncontrolled combustion is observed, there will be additional vibrations from the engine, and exposures to these vibrations will lead to wear and tear of engine internals such as piston, piston valves and piston rings. And if it is completely neglected, engine will seize up. And some people get confused with pre-ignition and knocking. In case of pre-ignition, this combustion takes place in the compression cycle itself, that is when piston is compressing air-fuel mixture, there itself combustion takes place. This combustion takes place before spark ignition. But in case of knocking, this is detected after spark initiated combustion takes place. And when it comes to performance tuning, knock sensor plays an important role, that is a successful tuning should have a knock-free engine. That is, whenever someone is tuning an engine or calibrating AFR values, they will keep on monitoring knock sensor readings and calibrate AFR and spark timing accordingly. And if they observe knocking, they will retard the timing. And to observe this knocking or to measure this knocking, we can use tools such as multimeter, oscilloscope and OBD2 scanner. That is, we can measure the output voltage of this sensor using multimeter and oscilloscope, and if we are seeing a peaks or high voltage, this usually means knocking. And by using OBD2 scanner, we can read fault codes. I hope you understood my explanation on the knock sensor. If you found this video to be informative or you learned something, please do like and subscribe to the channel. If you have any doubts, please let me know in the comments or DM me in the Instagram. I will try my best to help you out.